So design go and no-go gauges for checking a hole and shaft pair that is designated by 590, H8 and E9. So the very first step is to find out the diameter step in which this 590 lies. So 590 lies in the diameter step of 80 to 100. Okay, so it lies in the diameter step of 80 to 100 mm. Therefore D is to be find out as under root of 18 to 100, and it comes to be 89.5 mm, right? So this is the first step. Then the second step is to find out the value of fundamental tolerance unit. That is designated by I, which is always in micron. Okay, the formula of I is equal to 0.45 third root of D plus 0.001 D, and the value is in micron. Okay, so I is equal to 0.45 third root of D plus 0.001 D, and it comes to be 2.0965. This value is in micron, so we have to convert this in mm, so it comes to be 0.002096 mm, right? Now the third step, as we know, as the fundamental deviation for H type of hole is 0. So we have to identify this H. This is upper limit, this is lower limit. This lower limit is on the 0 line or basic size line. It means the lower limit is equal to the basic size. So the fundamental deviation is 0 in this case of H. So therefore minimum size of hole, that is lower limit of hole, is equal to basic size, and here it is 90 mm, right? Okay, so therefore maximum size of hole we have to calculate. Maximum size of hole, that is upper limit of hole, is equal to basic size plus tolerance. So now we have to find out the tolerance. So tolerance for H type of hole with IT grade 8. So here it is H8 type of hole is there. So having IT grade, this is the IT grade. Okay, so that is IT8, that is equal to IT8. So IT8 is, in this case it is 25i. Okay, IT8 is 25i, and that comes to be 0.0524 mm. Okay, so maximum, therefore maximum size of hole, phi maximum or upper limit of hole is equal to basic size plus fundamental tolerance. Basic size comes to be 90 plus tolerance 0.0524, it comes to be 90.0524 mm. So if you want to draw figure, this is hole, tolerance of the hole. Okay, so this is H8 type of hole, this is upper limit, this is tolerance, this is upper limit, that is equal to 90.0524, and this is lower limit, that is 90 mm, that is equal to basic size. Okay. Now the problem, in the problem E9 type of shaft is given. So for E type of shaft, we have to find out from this figure. For E type of shaft, this is E type of shaft, there is fundamental deviation. Okay, and that fundamental deviation is to be calculated from this formula for fundamental shaft deviation. For E type of shaft, the fundamental deviation is to be calculated as minus 11 d to the power 0.41. Okay, so for E type of shaft, fundamental tolerance, this is not tolerance, we are talking about deviation. Fundamental deviation is equal to minus 11 d to the power 0.41, and after putting the value of d, it comes to be minus 68.53. this is in micron, of course. Okay, that values, this fundamental deviation values, these are in microns, right? So we have to convert this into mm. So that is equal to minus 0.0685 mm. Okay, so therefore fundamental tolerance for E type of shaft with IT grade 9, so that is equal to IT9. So IT9 is 40i. Okay, so IT9 is 40i, 40i, and that comes to be 0.08 0.0386 mm. Now we are having tolerance for shaft. Okay. Now maximum size of shaft, okay, that is phi maximum of shaft is equal to, okay, for shaft, that is equal to basic size plus fundamental deviation. So here basic size is 90 minus that fundamental deviation value 0.0685, it comes to be 89.931 mm. Now minimum size of shaft, that is equal to phi maximum of shaft minus fundamental tolerance. So phi maximum is 89.931 minus tolerance is 0.08386, it comes to be 89.847 mm. We can draw the figure like this. This is the basic size line. This is the shaft, this is the tolerance. So this is basic size, this is fundamental deviation, this is the tolerance for, this is the tolerance, okay. This is the upper limit, this is the lower limit, okay. Now we have to find out gauge tolerance. We have to find out, because we have to design gauges, so we have to find out gauge tolerance and we have to find out wear allowance. So gauge tolerance and wear allowance. Gauge tolerance for hole is calculated as 10% of fundamental tolerance. So what is the fundamental tolerance of hole? So the fundamental tolerance of hole, the tolerance of hole is 0.0524. So 10% of this is calculated as or taken as, this is the tolerance for hole, tolerance for hole, it is 0.05. So 10% of this means 0.00524 mm. So this is the gauge tolerance for hole. Similarly, we have to find out wear allowance for hole. So wear allowance for hole is taken as 10% of gauge tolerance, this gauge tolerance, okay. So 10% of this means 0.00052 mm, okay. Similarly, gauge tolerance for shaft, that is 10% of fundamental tolerance for shaft. So here we have calculated the tolerance for shaft, this is the tolerance, fundamental tolerance for shaft, it comes to be 0.08386. So 10% of that will be taken as 0.00838 mm, okay. Similarly, wear allowance, for shaft, it is taken as 10% of gauge tolerance. So we have calculated this gauge tolerance for shaft. So 10% of this means 0.00083 mm. So this is how gauge tolerance and wear allowance of for hole and shaft is to be calculated. So because we have to design the gauges, right? Now, how this is represented? So we have to draw the figure like this. This is basic size, that is 90 mm. This is phi maximum and this is phi minimum for hole. Okay. This is the fundamental deviation. Okay. This is phi maximum and phi minimum for shaft. This is no go gauge and this is go gauge for shaft, sorry, for hole. This is gauge tolerance and this is wear allowance. Okay. This is go gauge and this is the value for no go gauge for shaft. The phi maximum for hole is 90.0524. It is 89.931 and this is 89.847. All these values we have calculated. So this is the wear allowance and this is the gauge tolerance. Okay, and this is the gauge tolerance. So all these values we have already calculated. So we have to put all the values. So here it is 0.00524. Okay, this wear allowance value is 0.00052. For shaft it is, this wear allowance value is 0.0008 and this gauge tolerance value is 0.0083. So for hole, we have to calculate the dimension for go gauge. Okay, this is IT8, okay, and this is IT9. This is the tolerance zone. So for go gauge, for hole, the go gauge value, it should be, this is the maximum value and this is the minimum value. This is the go gauge limit. This is go gauge is up to, this is the minimum value for low limit for gauge, go gauge, and this is the high limit. This is the low limit and this is the high limit for go gauge. So the basic size here is 90. So the go gauge should be up to this or up to this. So both in the upper side. So plus gauge tolerance plus this is wear allowance and this is gauge tolerance, right? This is gauge tolerance. Gauge tolerance plus wear allowance, or it is up to wear allowance. So both the values, I have not written the values here. So for no go, it is up to this 90.0524. So it may goes up to this value, up to plus gauge tolerance or plus 000. Okay. So this is the value for to check hole. These are the values for go gauge and no go gauge. Similarly for shaft, go gauge. So go gauge should be 89.931 minus, because it is below that, minus it should be up to this or up to this. So minus wear allowance minus wear allowance plus gauge tolerance. Okay, both value we have to reduce it. And no go gauge, the value is 89.847. So it is up to 0.00 because the value is here, or we have to reduce the gauge tolerance. So put the values here and you can get the answer. So this is how you can design the gauges for go and no go gauges for checking hole and shaft pair.